IC42 course, Module 3, Feedback Amplifier, Output Stage and Power Amplifier. So this module talks about different feedback topology available, what is feedback, different topologies and feedback amplifiers. And the next part, output stage and power amplifier, significance of output stage in any system, and different types of power amplifier or classification of power amplifiers, and parameters which influences the power amplifier performance. We discuss all these topics under module 3. In lecture 1 we talk about feedback amplifiers. These are the contents under feedback amplifiers. First, introduction to feedback amplifiers, general feedback structure, some properties of negative feedback, the 4 basic feedback topologies, then feedback amplifiers. So let's take first one, introduction to feedback amplifier. So first of all, feedback is defined as a process in which a part of the output signal is fed back to the input. So in any system, usually if the system is not having any feedback, means it is having input and some process is done inside the system and it produces an output, and output is completely independent of the input. There is no dependency between input and output. There is no connection between input and output, right? That is open loop system. When we talk about closed loop system, so there is a connectivity between output and input somehow, right? So that we call it as a feedback. So what is feedback? So part of the output signal is fed back to the input. Part of the output signal, it may be in the form of voltage or in the form of current, right? So sample which we take from the output, it may be a voltage or a current, and it is fed back to the input through a feedback network, right? Again, the feedback network may give you an output of voltage or current, right, as an input to the system. So ultimately, feedback is a network in which, or a feedback is a process in which a part of the output signal is fed back to the input. The feedback signal can be in phase or out of phase with the original input signal. So the feedback signal which we apply to the input is, it may be in phase to the original input signal, or it may be out of phase to the original input signal. So based on that, you can classify the feedback types. Majorly you can classify it as positive feedback and negative feedback. So positive feedback, original input signal, that is whatever the input we give to the system, and feedback or feedback signal are out of phase, that is a part of the output signal taken and given as an input along with the original input. If both are out of phase, then it is a positive feedback. And example of positive feedback, the system which uses the positive feedback is an oscillators. Next, second type of feedback is negative feedback. Original input signal and feedback signal are in phase in this. Original input signal phase is in phase with the feedback signal, or signal which is taken from the output and feeding back to the input. So both are in phase, and best example of this is amplifiers. So oscillator is an example of positive feedback, and negative feedback example is amplifiers. Let's take a system without any feedback. So this is what I said earlier. So you have one system, let's say it is an amplifier, with a gain A. A is a gain of the amplifier. We know gain is equal to output by input. This is Vi given as an input to the system or an amplifier, and V0 is an output produced at the output of an amplifier. So there is no connection between V0 and Vi. So this is open loop system, and gain A is equal to output by input, V0 by Vi. So this is the case where we don't have a feedback, right? So if gain is equal to 100, say let's say A is equal to 100, if Vi is equal to 1 volts, then what is the output voltage? So V0 is equal to A into Vi. V0 is equal to A into Vi. It is 1 into 100, 100 volts. So that is ideal case, right? So this is what the feedback amplifier without feedback. So if you have a feedback to the system, right? So then what are the advantages of having a negative feedback for an amplifier? Because we are interested in feedback amplifiers. So feedback amplifiers, we know that it requires negative feedback. So first we are looking into the scenario where why we need this negative feedback. What are the advantages of having a negative feedback so that it can be used for an amplifier? So first one, desensitize the gain. Means gain is less sensitive to variation of the circuit components. If any variation in the circuit components, maybe say current, any current variation due to the variation in beta, due to temperature variation, assume, so gain should not change, right? So gain ultimately tells you how much output you want for a system, right? So for a system, if you want 10 volts output for a given some voltage, okay, so that system should produce 10 volts irrespective of the changes in the parameters of the design of the circuit, right? So this negative feedback provides a stable gain. Stability is good if you have a negative feedback. Next, second one, reduced non-linear distortion. Output proportional to the input, right? So if you don't have any feedback, then the devices used means the circuit amplifier behaves as a non-linear circuit. It is more like a non-linear circuit, okay, the behavior of the circuit. If you use a feedback, then it behaves more likely a linear circuit, right? It is a any change in the input signal, the equal proportion equally output also changes, proportionally output also changes. That is linear linear operation, right? So we call reduced non-linear distortion. Okay, next, reduce the effect of noise, minimize the contribution to the output of unwanted electric signals generated. That means along with an input signal, original input signal, there are chances that you may get some interferences, right? Maybe external interference or maybe internal. Internal means noise due to the operation of the devices inside the circuit. The devices itself may produce noise. Okay, so those noise should not be get amplified, right? So it should not disturb at the output. So it reduces the effect of noise at the output. So which one? Negative feedback. That is the advantages of having a negative feedback. Okay. Next, control the input and output resistances. So by selecting the proper feedback types or topology, right, we see what is feedback topology, different types of feedback topology. So by choosing a proper negative feedback, you can have a control over input and output impedances or resistance of the amplifier, right? For example, generally voltage amplifier means it should have a high input impedance and low output impedance, right? So high input impedance and low output impedance. So it is possible with choosing a required feedback topology for an voltage amplifier. Okay, so you can have a amplifier with low input impedance and low output impedance. It is possible by choosing proper topology, right? So that option is open if you have a negative feedback. This option is not available if you have a open loop system, right? So that is the advantage. Next, extend the bandwidth, right? So bandwidth increases if you use negative feedback in an amplifier. Amplifier without feedback, bandwidth say 100 kilohertz. If you use a negative feedback for an amplifier, then bandwidth may increase to 150 kilohertz or 200 kilohertz, say 150 kilohertz. This is just an example. Okay, so bandwidth you can increase, right, by having a negative feedback in an amplifier. So these are the advantages of having negative feedback for an amplifier. But at the cost of gain, that's the only demerit, or you can say disadvantage of a negative feedback, having a negative feedback for an amplifier. Gain will reduce. If you have a negative feedback, gain will be reduced by some amount. Okay, so at the cost of gain, we have many disadvantages of a negative feedback, right? So there is a trade-off, right? How much advantages you want among this, right, over a gain. So anyway, you can increase the gain by having multiple or cascaded amplifiers, right? So even though if you use negative feedback and gain will be reduced, no matter, right? You can have multi-stage amplifiers so that you can increase the gain. Again, it is having its own advantages and disadvantages, but ultimately, so because of all these advantages, we should have a negative feedback for an amplifier, right? Any amplifier in today's world will be having a feedback system. Not only amplifier, in any system you take other than the course content, right, other than engineering, right? So definitely a system must require a feedback for better performance, right? So this is about the advantages of negative